Practice is there's problems, you dig a hole. Anybody watch Grand Designs? Or one of these building, I'm a big fan of this, it's a British programme called Grand Designs, and there's another one called The World's Most Extraordinary Buildings. It's on Netflix. So,
Extraordinary Homes.
Extraordinary Homes. So there's an architect on there that goes and talks about these buildings, and what a lot of happens when you build is that you dig a hole and then you find out that actually you thought it was rock and it's sand here, and then they go away and go back to the architectural engineers and ask for another problem, right? So, and occasionally these problems become so much of a problem, you have to go back to the architect and go, okay, well we can't actually build this here, and they have to go back to the client and say that, you know, that's a problem, right? There's a huge problem here. So we're already hinting at the fact that this, and then the client may make a decision about changing the requirement, changing their plans. Now, hopefully, of course, you discover as many of these as you can, as early as you can, because this costs money. Right? So if you're going down the design, then you have to make a change. Then it's a huge cost, and actually builders love this. So I have done quite a lot of work on virtual reality for architectural engineering, because the clients want to save money, the builders love faults. They love digging holes and not finding anything because they get to charge more. So as soon as they find, and it's called an in-process or a building alteration notice, that they do exactly what they're told. These pieces of paper are contractual agreements. So if you don't do it, then you do exactly what it says. So you dig the hole where they said, and then you go, oh, there's a bad problem. And then they make about 30% of their profits from these, what they call design revisions or build alteration plans, because they have to go back and then get the client to agree to changes. So it's the reason for putting that up, and it's a bit of foreshadowing what we're going to talk about next week, is that this is the sort of the design part. Okay? It's not to say there isn't design going on here. When an electrician actually wires up a kitchen, they're of course designing the layout because the architect won't say exactly where the wires go. So they're applying their best practice in a sort of subdomain. So it's not to say there isn't any skill here. There's design work going on, but in this process, this is the one where most of the decisions are made. So you make most of the decisions about what it is the client wanted, and in user interface, that's going to be the client says, I want a museum application or something to go in a museum. We're going to have to decide what on earth they want. And actually, when you talk about that, when you see that building, most extraordinary buildings, because there's one in New Zealand nearby, which I thoroughly love, which I'll try and go and see if I can. The architect, the client says, I would like a building, I'd like to take advantage of the view of the sea. And I have 3 children, and in 10 years my parents might come and live with us. The architect turns that into obviously something where there's an enormous amount of detail from very little information. So they've taken a small amount of information, made a huge number of choices to come up with something that's very specific that can then be built. Okay, and that's your job to do that for user interfaces now. Take a small amount of information, lots of plans, and then to something that can actually be built. And the prototyping that you've started talking about is a sort of interface between trying to do as little work down here as possible, or as few mistakes as possible, and make the best decisions, because prototypes help you think about the design and make choices. Okay, so interaction design then focuses on interactive things, and that people will use to undertake tasks in their daily life, right? So we used to think about, as I said last week, we used to think about interaction as something that happened between you and a keyboard and a screen to make you better at filing taxes or doing accountancy or things like that. But obviously now we carry computers with us. Almost all of us has got a computer on us, They are designed to help us in our everyday lives, and when we've got a few minutes, we're probably playing on them. I play Pokemon Go when I've got a few minutes spare, and it's gone from, it's something that's designed to take advantage. It fits into my life in a certain way, and obviously I try to make sure it doesn't take up too much of my time. But it also, my phone obviously helps with pretty much everything I do these days, keeping me on track, helping me drive a car around and so on. So how it's designed for that is important. So how it can do that is very important. And so on a phone, unlike previous devices we might have carried, it's got a lot of different functionality. And the way the functionality is divided up is through applications. And so that was the first huge decision that was made when building a smartphone, is that functionality is divided up into apps. And if you go and read the early history of the iPhone, that was a design choice they had to make. And it's really interesting because apps were something that Steve Jobs did not want on the phone, right? He did not want the concept of little icons that do different things. He literally didn't want it. And he wanted to have it that the phone would understand what you wanted to do, and therefore they would sell you one app that did everything. And of course, apps then took over the world, right? So there are apps now for everything. And I've used my phone for everything from being a spectrum analyzer. So I've used it to try and find ultrasonic noise in a laboratory setting, because we couldn't get one of our systems to work. So wandering around through to measuring rooms. So using it as a replacement for a tape measure when I couldn't find a tape measure, because there's an app which is pretty good at estimating distance travelled of the phone. So that's a pretty broad range of things. Okay, so interaction design focuses on interactive things, and to some extent, although we're going to look a lot at we're going to look a lot today at physical things, and most of your examples you've given me are things out there in the world that aren't smartphones. Later on in this part of 602, we'll talk a lot about apps and how they are designed to take advantage of the sensors and the screens and so on, because inevitably, when you actually do user interface design, most of it will be building an app, or at least there'll be a component of it, of building something for a phone, which acts as an interface, even if the thing which is controlling is somewhere else. Okay, so here's a definition of interaction design, and the reason for putting this here is it says very similar things: designing interactive products to support the way people communicate and interact with their everyday lives. I'm going to recommend that you use this book, so Priest, Sharp and Rogers, as a reference book for this module. Okay, so if you're going to buy this one, there are some copies. The library has a copy. It's currently on my desk. When it goes back to the library, I'll try and get it put into the 1 hour loan bit of the library. I'm not sure if I can do that myself. But the idea will be that you should read that at some point. It's at least this is the type of reference book which, if you go on and do this in the future, you'll want to pull off the shelf. So you'll need to read it at some point during this module, right? And it covers the same topics. The homework for this week is to read chapter 1. I don't mind when you do it, because there is only one copy in the library at the moment. It was recommended last year, but the library only has one copy. And they are buying more. So hopefully this week, 2 more copies will appear at the end in the little lounge area at the end. So for those of you who sit up here, have desks up here, there's some sofas over there, and they've got books and board games. Books for you to revise with, and board games obviously they can't work all the time. And then the library will get, there's a new edition of this coming in a month, and the library will get several copies of it then when the new edition comes out.
Just kind
Yeah.
coordinate around those. We ordered a couple just so we have it in the lab.
Yeah.
So just kind of coordinate with each other. Don't take them out of the lab. Kind of work with them here.
So I recommend.
The couches are really comfortable.
They are. I can vouch for the couches. Yeah. The key thing is, I don't want you to read it this week, right? I mean, I don't have to do it immediately, but just this is one of these books that if you carry on this field, you'll own a copy of it eventually, and you'll pull it off the shelf for sort of advice or to show somebody what you mean when they say I'd like to do this type of evaluation, for example. There are enormous numbers of textbooks on interaction design, and there are loads of good websites. So I'm not going to recommend that you buy lots of things because there's enormous amounts of material available, especially when it comes to case studies for design. Okay, but and in full disclosure, Yvonne Rogers is one of my colleagues at UCL. So that's not why I'm recommending this one. It's just this is pretty much the standard. It's not an esoteric niche one. This book keeps Yvonne well stocked in small Mercedes sports cars, right? Because they sell about 10,000 copies a year of that book, and she gets paid. Very, very, very few academics make any money out of textbooks, including myself. Okay, so because a couple of you had some background in some other design areas, so I'll just say a little bit about how to differentiate it from product design, industrial design, graphics design, and all these others. And historically, form of the object wasn't a primary driving factor in interaction design. Usability and this term called utility were the drivers, right? So you wanted something. Interaction designers were building things that made people smarter, faster, and more productive, right? I said that was historic, and the reason for that is it's changing very slowly. If you go to launches of new devices, launch of the Samsung S10 last week is a huge media event. It's one of the biggest of the year, right? And they're not selling you just a phone. They're selling it's fashionable, right? It looks nice. It's sold as a fashion accessory in some extent. That it looks good. It's visually superior to some of the other phones that are out there, and so you'll see that is changing. But we are mostly concerned with interaction, and that's what we're going to get into today. What is it actually that got to do? So, what does the interaction cycle look like? So, therefore, when you look at human-computer interaction, you see that there's lots of other adjacent fields. So you have design practices, and I've talked about some of these before, graphic design, product design, increasingly film industry. So there's an enormous amount of effort goes into both for production of, say, tutorials, adverts for interaction design, the visual look, the visual flow of interaction. So when you turn on your phone these days, you get a sort of nicely designed interactive thing, which is purely there to make it look nice. Right, so mine shows me bubbles for some reason, because I've got a Samsung phone. So when I turn it on, I get nice pictures of bubbles. I used to get like flow fields, but so there's a sort of visual look there, which is trying to, it's got some filmic elements to it. And then you've got some academic disciplines like ergonomics, psychology, design, informatics, engineering, but also the social sciences. So we'll talk about, I'll give you an example of one of these because I think that's very interesting. And then these sort of interdisciplinary areas such as ubiquitous computing, which we'll talk about later on in the module, human factors, cognitive engineering, HCI and so on. So, so it's very interdisciplinary, and as I said last week, user interaction design is sort of becoming a sort of field on its own. So, because these are somewhat well established, but so many, say, for example, artist designers or industrial designers now have to understand about user interaction, and they used to do it themselves. You see some really bad user interfaces, some bad interactions with nicely designed objects, which we'll see some examples of in the things you sent me. But now it's a sort of separate area that people that really think about user flow, user interaction with these objects. Okay, so let's jump in and look at some good and bad ones then. We sort of know bad design when we see it, and so the examples that you've sent me, and we'll go through. I'll do one first to sort of give you an idea of the sorts of things that we'll start thinking about when we start critiquing. So we'll start doing a little bit of that today, using the examples you sent me. But then next week we'll talk a lot more about how to use critique as a technique, and that will be completely unfamiliar to every computer scientist in the room, and most engineers actually. So standing up and being rude about stuff, it's immensely good fun, and it's actually a technique that you can use productively. So I use to inform design. So we often know bad design when we see it because it gets in the way. We come across it, we bump up against it, or it reminds us that the world is not how we expected it. And the windows last week were a good example. They turn on and they're noisy, so there's several aspects to that. One is the autonomy, lack of control, and I think we're getting control back in the future. The other is that they were just noisy, right? They were disruptive. So when they're actually moving, they sort of stop you talking, and that's important. And we often ignore good design as it facilitates our interactions and doesn't get in the way. So we ignore, for example, well-designed buildings because we don't get lost in well-designed spaces because we sort of understand the routes through them. So, for example, and this is a mini example. Let's contrast the science building. Everybody know the science building, the Rutherford building? Okay, all right. So it's new, brand new, and when you walk towards it, it's really very obvious where you can walk through. Right? And the reason for that is it's a sort of standard architectural trick. And you'll notice, if you don't notice this, then you'll forever notice this on buildings as you go in now. Whereas from lots of different angles, it looks like this. From lots of different angles, and it's actually quite well designed from the other side. By the way, I like the other side of the building, the one that faces the main sort of square, but because it's got this sort of curved bit in the front. And this is where you walk through. There's big glass windows, and it's quite dark, so it looks like an entranceway. And it sort of sounds simple. If you're going to have an entrance, you're going to have you have a door in it. But this idea that it's set back and you're sort of drawn in, and by the time you've walked here, you don't have very many options. Right? So as you walk towards it, before you get to the door, the turning left or turning right and going around the side is actually less of an option. Okay, so you're sort of drawn in, and it's sort of very, very basic sort of architectural engineering. At 6:30, this becomes a very bad design. It's because this door gets locked. Right, so if you try and do this after 6:30, this is a sort of bad design because they haven't fixed the problem that you then have to walk all the way around the building here and go up the side. So actually, you get to the door, you get all the way to the door, you don't know it's closed. And my card doesn't open it, yours probably doesn't. And actually, the way around is a real pain, right? So, it's okay, it's good, but there's also a bad design. There's a bit of bad design there. If you carry on going, though, you get to the engineering building, and then it's really not obvious, right? So when you get to the engineering building, there's loads of signs. There's more signs, and you come up to this building that looks like this. There's a door here, and then you have to go in and turn left, right. And there's really no visual clue that there's anything in there, because if you go up to a double door, which has an immediately just a wall behind it. There's nothing obvious that this is actually the way in. So people go in, a piece of people go in and they go left, or at least they stop here, and then they're looking which way to go. And it's sort of, you can sort of see there's a bigger space here, but you have to look. Right? So there's a point for sort of, the first one sort of invited you to keep walking. Right? It doesn't invite you to stop and look around, and that's important for if you've got a big building with lots of things going through it. Whereas here, as you walk through, you see people stop all the time, and then there's because they don't know if to go left or right, they have to look. Okay, did anybody notice another, we'll get into this bad design feature of this door. Anybody walk through it? Anybody spotted anything else that's obvious? You can go back, look at this. This is my thing. This is my thing for bad design, right? For my homework from last week. If you go through this door, it says, please open the left-hand door first. So it actually says on the door, open this one first. But this is the obvious one to open if you want to go that way. The reason for that is it's got a door which actually has from the top, it looks like this. So if you open the right-hand door, or not the left-hand door, then close it, it doesn't actually shut. Ever come across those doors? One of them closes on top of the other one. All right, so it's a pull door, and they're for other reasons. Two of you sent me glass doors as good and bad design features. But this one has another problem, which is that you get it wrong, and I do it all the time. And I just sat there, oh, do I know? To fix that, do I go back and open the left door? Because so people don't, and it's permanently left slightly ajar, and is therefore massive heat loss through that door. The doors left open is a huge problem for heating in building maintenance. It's a leading cause of heat loss. Okay, so there's a bad example. So it got in the way, right? So every time I go up to the door, I go, oh no, I'll open the right-hand door and shut it again. And I feel very, very, very slightly guilty. And then I just carry on because I know somebody else immediately afterwards is going to come and open it. Okay, so that's the type of thing we're looking for. And then if you're an architect, you could probably fix that, right? It's sort of obvious there's other doors. It's not a case where you can have a sliding door, though, because when you have sliding doors, you usually have two of them. For one of the reasons, and we're going to come to that when we look through some of your examples. Because you can't have a sliding door here, because then the air would just escape from the building. But you could you could hang the doors the other way, is the most obvious thing, because everybody opens the right-hand one first. Okay, right, here's the next example, right. So I planned these slides, or this example was suggested to me by a colleague. Does everybody know what they are? Because they're apparently not common in New Zealand. No? This is true. Central heating is not a common thing in New Zealand. The house I'm living in doesn't have central heating, but this is a thermostat.
Normally there are space heaters or.
Yeah. Okay. Anyway, this is a thermostat. And this isn't going to work so well in every home in the UK has one of these, right? Because it's cold for a lot of the year. But it's a thermostat, and this is degrees centigrade. If you turn it to 20 degrees centigrade, your house will get very warm. Well, at least according to me, it will get warm, right? So mine is usually at my house in England. It's usually set to about 17 or 18. Okay. Good and bad features. What's good about this? Very clear, right? It does one thing, exactly one thing, and it's very clear. The temperature's going to go up to roughly 18 degrees, 20 degrees in this case. Okay. What's bad? What's bad about it? So this thermostat sets the temperature, right? But what's it not doing? What's bad about it? Yeah, so it's the temperature. There's obviously some other control somewhere else, because you don't want it at this temperature all the time. Okay? Right, so if we think about that as a user interface criteria, so when you see one of these in the house, you'll usually see something else in the house that looks a bit more like this. And you'll see these, if you haven't seen these in the house, you see these in hotel rooms quite a lot, for example. So this does the same thing, right? And instead of a dial for up and down, because they have a screen now, they've got more functionality. Screens are very, very tempting. And you'll have long debates with colleagues when you do user interface design, is why don't we just put a screen on it, right? And then we can show lots of information. And this is just making it more complicated, right? So here are the buttons for up and down, okay? And now it shows you the most common problem with this. It has 2 temperatures on it now. So obvious flaws are that there's more functionality here. There's a lot more functionality. But one of these is the target temperature and one of them is the current temperature. And we can guess which one is which, right? I won't do it, but we can guess that this is the current temperature and this one isn't. This is the time, and you can have it on heat or not heat. I don't know why, because if you've got a target temperature, it's sort of, presumably it just goes to that temperature. That's what it suggests. If you put it higher than it currently is, it would heat up. If you put it lower than it currently is, it would cool down. Okay? But for example, this system's only one way, right? It only heats up. Okay, so there's sort of a problem with that is if you've never seen one before, you might think it's air conditioning, and it isn't, right? This is heating only. So this one sort of does both, and that's not obvious until you look down here and it says, oh, heat, and then you don't know, right? So then you don't know if you have to switch this to heat first or cool first, okay? So you don't know that. And then there's the get out clause, which is menu. And you just know if you press this button, all sorts of other crazy things are going to happen, right? So you just know that there's lots of stuff under there, and if you press that button, this whole screen will change and all bets are off. Then there's a couple of other buttons that don't do anything. They seem to be attached to this, because that's a common thing, that you have something that's sort of labelled as being close to a button, and that one, I don't know what it looks like a light bulb. Why on earth there's a light bulb on it, I have no idea, so I can't even read that. And so it's quite fun to do this, right? You can just sit there and go, that's terrible. But your job is to make it better, right? That's the downside, right? So a lot of user interaction design is done at this stage when they know these exist, because the control system is known, and the only thing you can change is the screen. Right? That's one thing, that's one sort of problem that you might be given. If you could only change the screen, how might you do that? Okay, and there's really great examples of that, how to change things only on the screen if you go to ATM design. There's a couple of really interesting case studies of redesigning ATMs so that there's fewer errors in the system. And there's one by a company called IDEO where they redesigned with the same, but they can't change the buttons, but they redesigned all user interactions with the system. Okay, but so you can change the screen, or you might change the unit, and obviously there's a famous example of changing the unit. So we can ask which one, sorry, let's not get that. We ask which one of these is better. The left or right, and the answer to that is, the one on the right is more obvious, it's simpler. If you were in a meeting room like this and wanted the temperature changed, we'd appreciate this one. In a room like this, where it was too cold and we could immediately do it, turn it in heating up. Right? We'd like the one on the right. If I was owning a property, I might want the one on the left. And the difference between those is really the users. So one of the points to be made about this example is not that they're good and bad, because the people who made this obviously aren't in it just to lose money. But this is going in somewhere where the people will learn how to use it and optimize its use. So they will learn how to use this because they've got a whole year, right? They've got a year of learning that they want to heat it in the winter, cool it during the summer, or vice versa if you're in the southern hemisphere. No, it's still, no, I get that right. I'm still getting used to being on the other end of the earth. And they'll learn the user interface, and they'll keep the manual, right, so they can figure it out. And to some extent, they'll get used to it, and they'll get more value out of this one in the long run, okay, because they'll save money in this in the long run. Okay, so the answer to which one is better really is this one is obviously simpler, this one's more complicated, but this is for a set of users that can deal with the complication, and we will talk some more about that later. Now, the famous example of an intervention in this area is this. Has anybody lived in somewhere that has one of these or seen one? Okay, so this was in the news last week for a reason. It's made by Google. And it's called, well, it wasn't made by Google. Nest was a separate company that Google bought a few years ago. And this is a thermostat. In fact, it looks very much like that one. Okay, it's designed to look like that one. It's a lovely piece of industrial engineering. It won loads of awards for its look, and it's got this is a dial, so you can turn it up and down. So it sort of makes an obvious thing. I want the heat up, right? You're turning something up. It's like a valve or a knob on something. Okay, and then it's got a bit of timing on that. So this visualization shows you the temperature is going to go up and down. But the key thing for this, it looks good, right? So even if you just had it as a dial, you can see somebody will buy this because it looks so good and it looks futuristic. And lo and behold, a lot of the early adopters of these were men in their 30s and 40s who like industrial design and wanted something that looked nice, or looked a little industrial, so not so domestic. But what was the claim for this? The claim for this was that you would just turn it up and down, and the reason that Google bought them is because it said it would learn. From you turning it up and down, it would learn to turn itself up and down. So what they were trying to do was the functionality of this, but with this interface. So this you can program it, and you can set times of days when you want it to come on and off. And this one is sort of up and down. So the claim was that you could get all of that by having a machine learn what was going on. Okay, and to some extent that's sort of obvious, because if during the day, if at 6 o'clock, if this is 6 a.m. and on 6 a.m. you turn it up because you've got out of bed, so this is the temperature and you've put it up to 18 degrees. You don't care what it is before that. Then you go to work at 8 a.m., 6 a.m., and then you go to work at 8 a.m. Okay, so you turn it down, so you don't care anymore, and then you come home at, say, 5, and then you turn it up again, and then you turn it off at 10 p.m. because you're going to bed. That's sort of obvious. You could learn that, right? Because you might do it again. You might press the snooze button, but it's 6:15 this time. Go to work, come home slightly later because you've been out with friends, but you still go to bed at, say, 10:30. The system can learn quite quickly that there's a pattern here. Okay, and that was what it was claimed, that's you could learn it. Saturdays and Sundays are obviously completely random, so you might be on or off all day. But at least from this you can sort of learn that at night you can turn it off, and during the day you can turn it off. So that you could figure out that these are the times at which you could go in or out. That the main times you don't want to turn it on or off. And that, of course, if you program one of these, that's the best you can get, right? So at home we don't have one of these. We have a really, really old one. So this is in the UK, and it actually has a dial on it. Big dial like this, and it has 4 pins that move around the outside, literally like this. So we can turn our heating on twice a day and off twice a day, and the clock goes round in 24 hours. And so literally there's a little pin that you say, I want it to come on at this time, go off at that time, come on at this time, and one of these is red, one is blue. So red is come on and blue is go off. And that's sort of, you can see that the machine is learning, trying to learn that, whereas before I would physically turn this in. You don't see these very often anymore, but we have actually replaced it now because it was faulty. And we had to replace it with something like that because they don't sell those anymore. Okay, so what happened? So that's great. You've got this connected device. It's Google though, so you've got this thing that learns. Obviously, it's just sending the information to Google. Google is then learning a plan for your house. But of course, they didn't make it so simple. You get apps as well, so you don't need to actually interact with the physical thing. You can do it on your iPad or Android tablet. You can turn it up and down. It looks the same. That's nice. Because you can just say, and there's a nice anecdote in the paper I'm just about to show you, saying, I can lie in bed in the morning with my phone and turn the heating up before I get out of bed. Because one of the complaints about these types of thing, the previous dials is, they're usually one of them in the house, and if you want to turn the heating up, you have to run downstairs and turn it up, then run back to bed and wait for the heating to come up, if you haven't programmed it. And you can then get energy usage out of them. So the claimed benefit of these was that you could train them, you could control them in multiple ways, you could then get an energy history, and people would be better. They'd save money. They'd save the environment eventually because they would be saving energy costs. What do you reckon? Did all of that happen? Did they save money? Some of them did. Most of them didn't. Most of them were too busy fiddling with it, right, to set it up and down. So the experiences of this system is still there, right? So this is a paper which I recommend you read at some point, called Learning from a Learning Thermostat. So this is at a conference called UbiComp, which is about, the UbiComp conference is an academic conference once a year, where there's lots of papers about ubiquitous computing. And ubiquitous computing includes things which are just installed in the environment around us. Thermostats was an obvious example of that, because they change the temperature. And they did a particular type of study here, which is quite interesting. They found people that had bought them, and then got them to run what's called a diary study. So they gave them a physical diary to fill in every day for a few weeks, and then they also interviewed them about their feelings about the thermostat. And actually, some of them were able to save money. But the reason they were able to save money is not at all about the learning. So the main point of this paper is the learning was a disaster. Okay, people don't understand what it's doing. They don't understand how to change it. And there's an anecdote in the paper about somebody who did this, but then their pregnant daughter came to the house, and they turned the heat down because one of the she doesn't like the room hot. Okay, so they turned the heat down, and during the period she was there, and lo and behold, this lovely device went away and just did that every day now. So now it turns the heat down at that point every day from one data point. Right? So it's trying to learn, right? It's a very over-eager computer that's trying to figure out what's going on here. So the problem was that that's an exception, and they don't want it to learn from that. So what they want is an ability to go in, figure out what this machine has learnt, and then edit it. And that's what users said they wanted. Is effectively they wanted this back, which is what is it going to do, and can I alter it? The people that saved money were effectively, this would learn to just take the min and max of this, essentially. That's actually, nobody knows what it learnt exactly, but that's what people suspected was happening. That instead of trying to, it wasn't doing anything smart, it just looked at the earliest time you got up, the latest time you went to work, the earliest time you got back from work, and the latest time you went to bed. And then the heating just got longer and longer. So one of the things that the people who saved money did is when they went to the house, when they left the house, they could log on to the app and say, oh wait, the temperature's still up, I can turn it off. So people who were very proactive, what effective they were doing was a remote control. So that's good, right? That's a good user affordance, or user capability, but it's not what it was designed to do. Okay, it was designed to be something you put in the room and leave there. Okay, so I'm talking too much as usual. So so here's a first thing to note down, and obviously you get these slides, so you don't have to write these out. All these discussions, this is basically revolved around 6 concepts so far. The first set of criteria you look at with one of these devices, with one of these systems, is effectiveness, efficiency, safety, utility, learnability, and memorability. So a system might be effective because it achieves its goal. It might be efficient because it's really clear. It might be very efficient to then get to the goal. It has to be safe. Obviously, this is sort of something we tend to ignore a little bit, but will become very apparent when you do augmented reality or even Pokemon Go, right? So Pokemon Go has probably killed people, right? Because they've been trying to catch and they've been walking across streets. And there has been a debate about that. Should people make games like that where they take your attention away from traffic? But in response, they've also claimed that they've probably extended the lives of millions of people by making them walk more. Okay, so it's sort of standard debate in sort of transport studies about, say, cycling. The most evolved debate is cycling. You might get killed on a bike, right? But on average, you're likely to live longer because you're doing exercise. Okay, so except in a few cities in the world where the pollution's so bad that you'll actually not get any of the health benefits. But in London, every time somebody on a cyclist gets run over, there's in the news. About 10 people a year get killed on the bike. But actually, there's a guy called Miller Herman. He's written a whole book about actually overall the quality of life and life expectancy went up because of cycling. That's one of the main arguments for it in London. So utility is sort of slightly subtle in that you need it to be for something. So does it fulfill the role you want it to do? So I have spent quite a lot of time on the computer with my dad trying to find him a program that allows him to plan his garden in the way that he wants to do it. Because I know nothing about gardening. He thinks I'm a computer expert, so therefore he thinks I can choose tools for him. And he has been through about 6 or 7 of these sort of garden planning apps. So the key thing is he wants certain things from it, and it takes quite a long time to figure out if you can do those things in the application. Then we've got learnability. So is it easy to learn what it does? Sometimes this is really obvious because it does exactly one thing, it goes up or down. But if you need to learn how to use that big panel control, you're going to ask questions such as, I'm going to need the paper booklet that comes with it. Okay, or I'm going to have to go and download a PDF from online. But in other user interfaces, they come with hints, tutorials, and that's one of the main advantages of having a screen or an app, is that you can show people how to use it. Okay, in the running system. And then memorability is a great one, which is if you're going to use an interface only infrequently, do you remember how to use it? And to some extent, that is tackled by having people make systems that aren't too unusually different from each other. Okay, so there's a lot of art in this last one about how do you make it memorable, and we'll come into a theory about that called affordances. Right. So that took a lot longer than I was hoping, or I was expecting rather, not hoping. I was going to go through some of your examples. So should we do a little bit of that and then have a break, or do you want to have a break first? Let's have a break first for 5 minutes. Just start again at just before the hour. Then we'll go through some of your examples. If anybody really wants to do their examples, just tell. Anybody want to do theirs because they got something? What I'm going to do is put up the pictures and get you to talk about them. Okay. So if anybody wants to go first, or really doesn't want to go first, just tell me when we get back. Otherwise, I'll choose them in random order. Okay. So let's take 4 or 5 minutes to. Otherwise, I'm going to do them in size order. File size order, top to bottom, which is effectively random, I hope. There's one more. Yeah. Yeah. Okay, well, it's. I'll get the first one up then, and. Oh, there we go. Yufeng. Hello, right. So we'll do this, we'll try and get through all of them, and we'll just talk with a couple of things, and what I'll do, if it's all right with everybody, is put them up on Moodle, and we can talk about, you can think about these examples. So we'll just do the pictures, and I'll try and get them as big as possible, so that everybody can see them. And yeah, do you want to say why you chose, for each one we'll say why you chose it. Yeah.
Because we talked about GPS as an example last week, so I chose that for solution about the accurate position.
Yeah. So GPS is an enormous utility. It's a function that's not available any other way, really, telling you where you are on the planet. As we talked about last week, it has some difficulty with understanding exactly what it does. So we could argue about whether or not it's effective or not, because when it's wrong, it's quite badly wrong, right? It can send you the wrong way on the street. It can be confusing. And I've sat in a talk about, so your slide is about this dual frequency with the with getting more satellites. So there are more. GPS is complicated. We'll talk about it later in the term. It involves satellites. The USA put up the first set of satellites. Now China, Russia, Japan, and the European Union have put up other satellites, and they all work in roughly the same way and not the same way. So you can get dual band, which is the Chinese, with the Chinese system I can't remember the name of. You can also get quad band. You can get receivers that can receive all of them. But that's, yeah, it's a good example of something that has very, very high utility. And next example, this design, this scooter, yeah. Yeah. Do you want to defend it? Good or bad?
Yeah, I think it's good because it's easy to fold up.
Yeah. Yeah, so my son has a scooter. It has a button like this. It also has a little sticker next to it saying, please mind your fingers when you collapse the scooter, because you can easily chop the end of your finger off when you collapse it. Yeah.
That's the problem. So it's just you use your feet to
Yeah.
the button.
So we would not consider that's a safety issue, right? We would not consider that to be a user interface issue, except that you have Lime scooters here, right? And now it's a user interface issue because they can remotely turn down the speed. Those things go at one heck of a knot. I almost got run over by one at the market in Rickerton Bush at the weekend. Somebody was doing burnouts on a Lime scooter on the way out of the park and managed to leave lots of rubber managed to get rubber skid marks on the pavement. But that's a software issue now, right? It's done like a motorbike. I think they've got grips. I have not been on one yet. They've got grips to speed up. I know there was some way of speeding up, but it's a software thing, how fast it can go. So they're actually having a debate about whether or not to turn the top speed down.
I
Yeah.
bought this one.
Yeah.
My friends will help me to bring it to New Zealand next month.
Yeah.
At that time, we can test it.
Yeah.
The other thing about, did you hear about Lime scooters today?
No.
So Dunedin and Auckland outlawed them.
Right. Already.
They're not allowed to be used in the cities anymore.
Well. Oh yeah.
Christchurch and Lower Hutt have not followed suit. Christchurch saying,
Yeah.
they're so popular here. Could be a money thing.
Yeah.
So this again, they say a software issue. I just saw an article, a man was charged for 111 rides. He's never been on one before.
Yeah. Well, the thing is that eventually the brakes have to be under software control because you can't steal them, right? So there's a piece of software that can turn the brakes on or off. That piece of software must be dictated somewhere by GPS because they're geolocated. So if you start taking it a long way away, it's going to stop. Therefore, it's somewhat related to GPS. Somewhere in there's a piece of GPS software. And we know how bad GPS can be. I've already told you, and you're going to see experience later in the term. Right? That GPS can be bad. Okay, door handles. Door handles. I love door handles. You've got a door handle next. Bad design. Yeah, and I agree. This is. Yeah. So I asked you to read Don Norman's book. He has a door handle example in there. This is a lovely door handle example, right? What does it do?
It's a bad because the shape.
Yeah.
It's hard to use.
Yeah. So I can speculate for several reasons. One is it's not clear what to do with it. It sort of suggests turning that thing, but you wrote that it turns the wrong way, right? So if I was going to open that, I'd turn it that way. But actually, that's a mechanism. If that's it can be either way up, that way. If you had that in a bathroom with your hands wet, that would be very hard to use, right? So you'll notice if you walk through a hotel or a house, they often have different handles in different places, even there, just because of the reasons. Same with pull switches. So our wall has, the bathroom here in New Zealand in the house has a switch on the wall. Those are banned in the UK. You can't have wall switches in the UK in a bathroom. So you have a pull cord. They're all on pull cords from the ceiling.
Wow, really?
Yeah.
Wow.
It's just a different, it's considered to be electric. I don't know what your mains voltage here is, but ours is 240? Right, okay. So, but there's a lot of volts behind the switch, so they don't want you to touch it with wet hands. So you'll see that. Go to a bathroom, where are the light switches? Oh, there aren't any. In buildings like this, they're automatic, okay? Which means to a lot of wriggling around when they turn off because they're not thinking that you're reading your phone in the bathroom. The phone goes off. Okay, so I love that one. They're great door handles. People who do industrial design still design door handles, right? You could go to magazines, go to a magazine, get something like Architectural Digest, something like that, and you'll find interior designers still trying to sell you door handles and taps and things like that because they think they're better or they have better affordances. And then last one, I think. Right, so some windows. We've done the windows. We won't rag on the windows too much here. Right, next is Riccarton Mall. Riccarton Mall. It's a yeah. Good design. Yeah.
Yeah, it's very clear and people can easily get information.
So it's a map which is interactive. Yeah.
I will show the tonight real life pictures for the store.
Great, yeah, so most of these are not interactive, right? There's obviously a cost-benefit analysis to the people installing them. If you install a touchscreen, people will break it. It'll just wear out. And paper is cheap, right? So competition is a piece of paper with a map on. Okay? Now, most people who use moles are habitual users. So don't ask me how I know this. I have done some design consultancy in the past for somebody installing AR into a mall. And they said that most people who go there have been there more than once. So that's why they don't have these interactive things when their key thing is trying to get people to go back as entertainment. That's why there's always a cinema at the end of Riccarton Mall, right? So they want people to go back repeatedly. That's the main challenge in designing a mall. But yeah, good design. And then you've got buttons on the steering wheel. Yeah.
Because all the button is the same shape, so I just need to put my finger on the button.
Yeah.
I can feel which functions, so I don't need to pay attention to.
Fantastic. Yeah. So car design, right? Lots doesn't change, as we said last week, but Lots is very, very heavily designed. And this one, I really like this example because you've got a plus which is bigger than the minus. So you run your finger down it, you can tell that one's, you can get the volume up and down. That's really easy. That's great. Good design. Nice piece of design there. The functionality is always the same everywhere, right? So on my car, it's a Toyota, quite an old one. There is this functionality. It A, doesn't work because it's an old car, and B, it's they're the same button. Yeah, Rob.
And the minus is keypads. So
Yeah, the minus. So this one is literally bigger than that one. So it feels like it goes in. Yeah, it goes in, and you can feel it's smaller than the top one. It's a very subtle feature, but again, if you look at, you went back to that control, the heating control. The buttons are red and blue for hotter and colder, right? And one of the classic examples of this, I think Don Norman has in his book, is shower controls, right? So which way do you move the shower handle to get it hotter and colder? The answer to which is don't hypothesize correctly. You're correct, just make sure it's the right temperature before you get in it. Okay, and then bad design, Apple's book. I think this one's great as well. Yeah, what's the problem with these buttons? Yeah.
Because personal bookshelf is library.
Yeah.
Actually, it can keep the ebook that you brought. The third is the library.
Right, so this one is a good example where the user has to have a hypothesis first about what it is. If it's a library, it's where you find things. Okay, but that's not a library, that's a bookshelf, right? So, as you said, so if you know what you have to learn that, and you can imagine that that's not the same. So it could be easy to learn. You're only going to get it wrong once in the app, but then somebody else's app might have a different one. So once you've seen it both ways, it might be not so memorable, and that's one of my main complaints about my phone is it keeps changing things. So I can't. So you then have to learn it the other way around. Okay, and curtains. What were curtains?
Because in my conceptual model, all the curtains need to put two sides.
Yeah.
Or just put one side. But this one.
This is two. So this bit is two.
Actually, it's two individual curtains.
Okay, all right, yeah. So there's probably a reason for that. I mean, you look at these things and go, "That's it there." You often think that it's quite. I like it as a hobby, is figuring out why somebody did something that specific way, because people are doing the best they can, and it may be that the curtain doesn't go on the other side because of damp, for example, right? So maybe if you put the curtain in the other corner, so there's probably a reason, probably, not always, but it's nice to think about. People had good intentions when they did that. Okay, next one in terms of size. Yeah. Okay, so this is more complicated. If we've got cars, right. Good, bad? Yeah.
I think it's good. More message and more information that driver can know immediately.
Yeah, so there's one really worrying thing about this image, as far as I can tell, which is that it's flicker. Flicker on the console. So why do you want flicker? I'm not sure. But there's obviously console design is a huge issue in cars. Good information, everything's available in this type of interface. You can see lots of different functionality, some of it for the driver, some of it for the passenger. Okay? And your opposite, I thought...
Is that the passenger or is that the driver right there? Did you take this image?
I just made this picture from the website. And this is maybe the driver?
Okay.
I think it's the driver, yeah, because there's more console information here.
Yeah.
So, yeah, and then...
Controversial that what the driver's doing while they're driving.
Yeah, so for example, GPS in cars, again, is an issue that's come up multiple times. In cars, when you get an in-car dashboard, it's almost always in a car-up direction. So all the directions are given to you with respect to which way you're driving now. When it's on the phone, it's switchable. Okay, you can either have it map north or direction up. Okay, And that is a debate where you can imagine laws about it, and there have been proposals for laws to make it one or the other and not both, because somebody can misread maps, and if they misread the map, then they... So I always do map north, and my partner, she always does car up when we got directions, and we hate each other about this specific thing. When we switch drivers, we have to fiddle with the app in the car to switch it. But again, if you want to get examples of where the state of the art in human-computer interaction is, cars is one of the places you'll find it, especially in high-end cars. So you'll see, if you want to see the best augmented reality in the world at the moment, don't look at HoloLens or HoloLens 2, look at the Mercedes S-Class, because they've hidden inside that a display which allows you to look outside the road, look on the road and see all the controls of the car out on the road. And actually, it's when we get into that, you'll find there's actually 7 different places you can focus on the display. So it's actually really quite sophisticated type of augmented reality. The only reason it works is because they've obviously took up most of the dashboard to install this display. So it's called a head-up display in that case, where you just put the information out through the windshield, and that's excellent user interface design. Lots of work done on it. Yeah, immense amounts of technology put into that.
Lots about cars. So
Yeah.
the bad thing about the high-end Teslas, they have a really nice big touchscreen that you cannot operate without looking at it. Whereas if they had a physical knob,
Bad design, there you go. You're channeling Rob. We're already tuning in. So huge. You'd think if you've got a user interface. Sorry, I'm preempting what you're going to say. What were you going to say about this?
I think this, the automatic driving car makes the HMI, is that HMI? Make that
Yeah.
useless because you don't need human to control
Yeah.
it.
So there's lots to say about this, but yes, the screen looks good because you can have a large interface on it, but large interfaces, obviously, you can have more things on, and that's not necessarily a good thing. But your specific point about the interface between this is actually not true, because you actually have to keep your hands on the steering wheel even when it's driving, so it's a fake press publicity anyway. But it's the interface between the two, right? So most of the crashes have happened when somebody hasn't understood that they must drive and the car can't drive, or they've wanted it to and they can't, and it can't. So the car, they wanted to put it into automatic mode, but the car won't go into automatic mode. And then Elon Musk is running around saying that these things will be automatic by the end of next calendar year, which is nuts, especially if you're a cyclist, right? Because these things literally have trouble seeing cyclists because of the way they work. So we'll talk a little bit about cameras and things later on in the module. Now, you had another good example, which was face recognition. Yeah. So this is more of a utility than an interface. Have you got a phone that recognises your face?
Yeah, so I think this is more convenient than the fingerprint.
Right. So you said that you prefer this to that,
Yeah.
right? And because it's faster.
Yeah, faster.
It's more efficient. It's much more efficient. It's easy to look. Obviously, it's easy to look. Effectiveness is arguable, because in this case, effectiveness is about security. If it only ever unlocked on your face, and it could only be your face, then obviously it's doing the purpose it requires. So it is, because effectiveness, like only unlocking on your face or your fingerprint, is part of the safety of the system, because if it does fail, then somebody could steal your identity. Okay. So other people. How do other people feel about face recognition for phone unlocking? Would they do it? No? Don't like it? Why not?
It kind of seems a bit like your privacy is being...
Yes, yeah. Somebody somewhere knows what your face looks like. Same with fingerprint unlocking. I sort of hesitated for a long time about unlocking my phone. I stuck with a pin for years, right? Because if they learn the pin, I'll get a new one. And then I've been in too many sci-fi movies where people's fingers have been cloned and eyeballs scanned and so on and things like that. That these things are sort of insecure. So if somebody gets that information, it's not, you know, there's nothing you can do about it. It's out there now. And yeah, I'm the same on face. I don't want to unlock my phone with my face because, you know, sometimes I'd worry about it working. Yeah.
Facebook use it all the time anyway, face recognition. So if you want to search a picture and then...
Yeah. But unfortunately, this isn't a security course, but yes, face recognition. I recently logged into Facebook again. I stayed off it for 10 years. I had a call. Rob's been flagging me on photographs for 10 years. Every so often I get an email saying Rob's flagged me on another photo. So I logged in again about a few months ago to find that Facebook knew exactly what I looked like, and I hadn't logged in for many years.
It's not my fault, is it?
It's you and Yoshifumi, and he seems to tag everybody in all his photographs. Yeah, and so yeah, this is user interface design. Well, I'm going to deal with this over the next few. So I think what they're claiming is my Samsung. I use it with a finger unlock now, mainly because I use it one-handed sometimes. And I've started wanting to use it. Got more into using it one-handed when I'm running. So they claim that the data never leaves the phone, and actually, sort of you can see that. Now that you can architect the system, so we could learn the phone, that would be good. I want to point out about this data leakage. I forgot to mention this with Nest. Does anybody know why Nest was in the news this week? Yeah, Nest, the thermostat. It has a microphone in it, right? And so 8 years after they started shipping them, they realised that Google has been putting these microphones in everybody's houses for 8 years, and it was. And because they've just enabled an Alexa on the Nest, and everybody went, you can enable Alexa, that means that you've been able to record our house. And there's been bugs about that. So there have been, if you get people have been asking for their data off Alexa and Nest. So in Europe, you can demand your data off these companies. I'm not sure about over here. And people have been found that they've got audio recordings from other people's houses by accident, things like that. So we all talk about that. Privacy is becoming more of a user interface issue. Is it obvious in the interface what's being captured? And at the moment, if you see a screen, you should assume there's a camera there and a microphone. They cost nothing. Right? So a camera costs $1 and a microphone costs about 10 cents. So people put them in interfaces anyway, just in case they can think of a use for them in the future. Okay, right. Next in size order, and we'll do this for another 5 minutes. So apologies if we don't get to...
The other thing is the no-look thing. So the fact that I can unlock my phone with my finger, I don't need to actually look at it in order to... And I think that's
Yes.
this whole notion of no-look interfaces is really important in cars and
Yeah.
you just don't... Why do I need to look at it?
Yeah, so
There's no reason for me.
there's some attraction to having a knob on the back of this one. So this is Samsung S9. You put your finger in a specific place. The S10 has it just in the front. Because you can do it with your thumb, but I think you have to get it within a target area. I don't think it's the whole screen. So,
Even when it's close, so it shows the area where you are
Oh, okay.
It takes
Yeah.
conscious look at it.
yeah. So you have to get better at metrics. I bet then. So we could just do a whole lecture about things I hate about my phone.
It also launched a foldable model.
Yes, well, Samsung did well on that, but then HTC released something that looks even more interesting.
Why?
The
Chinese brand.
Huawei.
They have just launched, which is a better
Yeah.
looking one.
Yeah, because the screen's on the outside.
Yeah.
But then you can't put it in a case. So it's going to get down. Anyway, these we're doing the work, right? So they obviously didn't. Somebody's decided that the screen was people who wanted a foldable screen didn't want it on the outside to get one screen versus the Samsung's two screen. Right. Glass doors, push and pull.
Yeah. So
Yeah.
I came across this a door somewhere in the city where there's no handlebar on the side where you have to push because
Yeah.
you don't need one, right?
Yeah.
Whereas on the side where you have to pull, there is one. It's kind of self-explanatory. You don't really need a handlebar where you
Yeah.
have to push the door. You just do it with your
Yeah, I'm always reminded of that cartoon of the Far Side. Does everybody know the Far Side? School for Gifted Children. With the no, you can look it up afterwards. That's right. I mean, there is a convention. There is an architectural convention. If you go to architecture school and you read through the book, there is the push is a vertical bar and pull is a horizontal bar. But you see it broken all the time by builders who don't know the rule and just install the doors backwards. Literally, they put the doors on or the handles on backwards. So then if it's a fire door, they go and fix it. If it's not a fire door, they don't fix it. These ones, they look like the pull, the push, but they're slide. So that's sort of, you'll do that a couple of times and then go, that door can't actually move all the way out, and then because it'd be a hazard.
Even to the one when we just enter the lab,
Yeah.
push or pull is not mentioned. So it's a little.
Yeah, yeah. And then of course it's on a card lock, so you've only got about half a second to get it right. So, okay. So doors, yeah. That's why architects are still here, right? I mean, they're still coming up with ways of doing that. Bad design, and then the road signs. I didn't know about this, so this is new for me. What is it?
Okay, so I haven't been to other countries, but when I went from India to Australia, I noticed that the road signs in Australia, they're quite blunt. They're in your face, quite rude, but then I think that's what matters, you know. You don't need to really play around with words because you need to convey the message. I think something like, you don't wear a helmet, you're stupid, or you die, you know, it's so blunt.
Right,
And I
okay.
think you need it sometimes because...
It's unlike the English version, which is please slow down.
No, it's not. It's quite blunt.
Slow down, right.
But I think you need that. And also,
Yeah.
so in elevated regions, when there's unpredictable rainfall, the visibility is quite low. So they have like electric signboards where
Yeah.
it's permanently lit up, so you know
Yeah.
visibility is quite good all the time, even when it rains heavily.
Yeah, so one thing I noticed here in New Zealand, for example, is zebra crossing. What I call zebra crossings. They're more dangerous than other countries, and I think they're having to improve the sign. So in the UK, they don't have an orange board. They have something that flashes. It's called a Belisha beacon. So if you have a pedestrian crossing like that, it has something that flashes on the top for the same reason. But design in road design is also really fascinating because there's an amazing amount you can do with paint. So I went to a seminar once and somebody basically designs paint for roads and saying that you'll see on the road I live in, there's painted fake speed bumps. So they've painted it exactly like a speed bump, but the speed bump is not actually there. Right, and the reason for that is it's outside of schools, so actually it's more safe to have a fake one than a real one in case in case kids are in the car or getting unlocked or something. Right. And you kindly did one which was actually a website, so it's trying to get an interface rather than, and this is a fairly standard one. What's the problem?
No, so I just felt that these websites,
Yeah.
so when you look for part-time jobs, I just wish there was a filter that, that said student jobs, because when you look for part-time jobs, it's all,
Yeah.
there's a very restricted timing, whereas when students are looking for jobs, obviously they would look at a more flexible timing. So, if there was a filter that specifically said student jobs, and also if they had like visual icons that said for each job, you would need a driver's license or you would need a car. Visual icons that would be, you don't have to really go into the job posting to check whether you would need these things. Just a visual icon would help. So you don't even have to get into it.
Yeah, so that's a very common one with websites is the filter. Somebody did some software engineering, came up with a database where student jobs probably aren't even flagged. So the user interface designer has been told that we'd like to filter on student jobs, but they can't without just string matching, and then it become a problem. The one I hate with websites is Trade Me in New Zealand. The one you've probably all used this now. Basically eBay, but it doesn't have a search ordering for total cost with shipping. Right. So eBay got this in the UK a few years ago. You can sort by total cost including the shipping because people obviously list stuff at 1 cent and then $6 shipping, and then it's really annoying because you have to read everything anyway to find out who's choosing the least. Maybe they'll get that eventually. Yeah. And then refrigerators. Yeah.
So back in India, we have the freezer on top, but over here it's at the bottom. So I kind of had a lot of difficulty in I just assumed that the freezer was on top and sort of stored things that way. I just wish
Yeah,
sign that simply, says that that's the freezer.
Generally, it's
It's
on
just-
top, no?
What?
It's on top, generally.
it is. Yeah, mine's on top.
Here, wherever.
Yeah.
New
Really?
Zealand, there's no
That's right.
standard. Some have them on top, some have them on
Yeah.
Okay,
bottom.
because wherever I have
Side by
been, it's
side.
kind of the bottom.
Remember side by
so-
side, they have the freezer and the fridge.
That's strange, okay, because wherever I've been, it's always been at the bottom, so I thought it was like a cultural thing.
Okay. Okay. I think we'll try and do some more of these. We are running a bit behind what I hoped, but it's okay. It's good feedback on these. Okay. Force touch and 3D touch.
Yeah.
Yeah.
Yeah, I like this design because people click one place in different ways, such as once or twice quickly or in different force.
Yeah.
It will appear many functions.
Yeah.
Yeah.
So this is a case where interface, we've got more functionality in the interface from just clicks to multiple. You get soft pushes, hard pushes, and you can add more interface complexity to it. It is a case where you've got more, you've got better components in interface, but obviously some people will never discover it. It's like double clicking on a mouse. Some people just never ever use double clicking. They just can't do it, or they don't like it. So yes, it's a good functionality, but it's not. I don't think it's clear if it's necessarily a good user interface or not. But
Sorry, I don't know what.
right,
Yeah.
right. I want us to get to this one: omnidirectional treadmill.
I like this one because
Mm.
this machine can combine two things I like: exercise and games. Yeah.
Exercise and games, right? So we'll come back and talk about this one later in the year, I think. But yeah, it's in virtual reality, you have this problem that you can't walk very far, so you need some way to go long distances. Usually that's by pointing your hand and pressing a button, and you either jump or you sort of skate along the ground. You could really walk, like where you could walk on a treadmill like this, and it moves you through the space. It's more like real walking. It is more like real walking. It has to be said, but it's hard work, so you get tired.
Yeah.
So whether or not that's a good interface for a game or not is arguable. Right? It depends what your objective is. If your objective is to be as efficient as possible, then probably not, because it takes energy, and you can be faster with a joystick. If you want to train somebody to do a task like so these have been evaluated and developed for army training, because it's important that the person understand that they can't walk 20 miles or they can't run at that speed. So then it's a constraint. But it is more fun. It is just generally more fun to walk. So we'll see. These haven't made a huge impact on the VR market. They originally started to sell them into the home, but then they were getting they're big and expensive and hard to ship. So there was a Kickstarter project. Has everybody come across Kickstarter? It's a sort of, for those who haven't, it's a website where you can, people who want to build something, product designers usually, or interaction designers, they have no money, so they put up a website and they get people to bid to contribute towards getting this thing built. So famously, the Oculus Rift, was a Kickstarter project, along with some other sort of big early user interface systems. And there was one of these called the Vertuix Omni that raised money on Kickstarter. I backed it on Kickstarter.
We did too.
$400. It was on the Kickstarter. Then they told us what the shipping would be from the US to the UK, and they offered would we like to carry on or not. And shipping from the US to the UK was $400. So it was $800. Did you buy one?
It was $750 or something by the time they started shipping. They said we cannot ship to New Zealand.
We cannot ship to New Zealand. So it was big and it failed as a product.
Yeah,
So no,
but we are getting one.
Yeah.
It's on its way here
Yeah.
because somebody in the States bought one, Kai from
Yeah.
Matterport. He bought one and he's like, Rob, do you want it? I'm like, yeah. He said, you can have it for free if you pay for the shipping. So we're shipping it from California to the lab. It's on the boat. And it will be here very soon. But it's not this device, it's a slightly different one.
Yeah.
But I'm very skeptical of this sort of thing. It's not actually, that one's not actually a treadmill, right?
None of those ones are.
There's no belt, it's
No,
just
no.
shoes.
Yeah.
Yeah, you have to use shoes or
Okay, voice control. Why is voice control bad?
Yes, if the environment, if you are very noisy environment, the machine cannot know what
Yeah.
outside.
Obviously, enormous amounts of money has been put into voice control recently. They're getting better, but they need to be online, many of them. So when you talk to Siri, didn't hear anybody, then you have to send data to Apple, and it actually doesn't do voice recognition on your phone. It does it on the cloud and then sends it back. So again, it's a privacy issue. It doesn't always work, which is the most frustrating thing. Yeah. And then doors. More doors.
Every building I know, we can watch this door. I come across something about this because I walk past by the door often open.
Yeah.
So I
Yeah.
think it's wasting energy.
Yeah. If you have small children, eventually they will spend half an hour with the door running in and out it and trying to be so still that the door closes and then jumping around. But do you notice there's two? There are two here, and there's usually two, and so there's not much. The volume of air that goes out if somebody accidentally triggers it is minimised. Okay, right. So let's try and do the others, and then I'll hand over for Rob for a bit. Okay. Who is it, this one? Yeah. Good because
it addresses the space issues of the plugs because it won't infect the each plugs.
so this is an adapter and USB, and you would make so many friends in an airport with one of these. So there's people that make these peripherals have to do good design, right? And it's a very innovative market, changing all the time because they're not Apple. They can't rely on their brand. Nobody's heard of this company, but they just have to make things that are very functional, like take up, save space in your bag. In fact, I was looking at that going, that's actually, I could imagine buying. I have enough plugs now. I've bought so many connectors now. I have that could have saved me lots of space. So yeah, great. Then you've got a classic design. These things, right? Angle poise lamps. So product designers will learn about these, right? Because it's sort of so iconic. People call them the Pixar lamp now, and I used to remember the name of the designer, the original designer of this. Sorry?
Luxo? Oh, the original person?
The original designer of the lamp. Because if you buy an original one from the original designer, not somebody's copy of it, you'll pay hundreds of dollars for one, for an original angle poise lamp from the designer. And that is one of these issues where it's a great piece of design and it's protected. And the designers sometimes get, they sell specific designs because they're so well appreciated and so different. And then a favourite example, wrong one. Billions of dollars in this problem, right? What's the problem?
It has mistakes in plug-in because it has up face and down face.
Yeah. Yeah.
Try once.
Yeah, so do you want a heuristic? If your plug has holes in, so if you look at a USB plug, it sometimes has two holes, and that's almost always up. There you go. Free bit of, almost always up.
Yeah.
So that is the heuristic. That is the heuristic. It's supposed to be that way up. There is. If you read the document, I have read the document. Don't believe it. Don't ask me why. I'll just carry on for too long. So the two holes are supposed to be at the top normally, and hence USB-C, right? So USB-C and Thunderbolts and Lightning connectors are reversible because too many people. The problem is not that they don't connect; it's that people put them in the wrong way. They can damage them, and that's the problem. But you still, we won't have time to talk about this later in the course of the thing, but the plugs, the reason you still see all those plugs is because they're designed for different reasons. So you still see micro USB, there's a little thin one and a mini USB, and you'll still see USB-C. Those ones are going to be standard, they're going to be around forever essentially because they're designed for different things. So for example, the little micro USB one, which is what we used to have on our phones, is engineered so you can pick up the thing with it. Its mechanical engineering is such that it's very strong, and if you pick it up, it will probably hold. And they mean different things. So the plugs mean different things and different. Cables is every VR group, HCI group, has a box somewhere with cables that they don't use but can't bear to throw away because they never know they might want this thing again in the future. So yes, USB is a.
My Japanese colleague says that it's more than 50% of the time you put it in the wrong way. Much more than 50% of the time.
Where's that?
Usually you try it, and that was the right way, but it doesn't go in. And you try it the other way, and that's the wrong way, so it's not going to go in. You go back to the first way, you plug it in. Why didn't it go in the first time? And that's not your problem. It's a design problem. Or maybe.
Sorry. Now your pictures came through, Laura. Rather pixelated, so you'll have to say what they are.
Yeah, I may have saved them in low quality accidentally. So the first one is obviously this Instax camera, and I really like the design of this just because it's so simple.
Mm-hmm.
There's a button to turn it on, the lens comes out, and to turn it off you just pop it back in again. And then the second one there is the Facebook Messenger chat, which you can use on your phone, and you can go do other things. So I was searching on Instagram, and it just pops down to a little square in the corner.
Right.
So
Yeah.
people multitasking.
Yeah. So that's a functionality on the phone which has only just become available because it requires a high-end phone. So app design, you can make money doing app design at the moment. They're just desperate for programmers, and the reason for that, there's so many different phones out there. So the user interface that you see on your phone will not be the same as somebody else sees on another phone. And that's to do with both the screen layout, the buttons, but also just the capabilities of the phone. So I've shipped software that runs on mobile phones, and dealing with older phones is just hard work, but then the stupid things keep changing as well, getting faster and getting different windowing systems. The one on the left is a classic thing, or something we'll talk about next week, which is you want there used to be this phrase in cameras called point and click. That was it. That's what they used to sell cameras in the 70s and 80s. You could point them and you click a button and it'd take a photograph. And then they just get more and more sophisticated. So camera phone cameras are a case in point. They're getting really sophisticated now. And you can buy professional modes for them. So it's an interface where you might want to have two completely different versions. You want it on, take a point and click, and then if you want to take professional photographs or you want to mess with all the settings and do the focal stops and so on, you want a different interface, and so you want to switch. And you can often find in a user interface, very commonly, expert versus amateur mode. And this is a case of a camera which is just chosen. We'll just do the amateur, the non-professional mode. Right, sorry, Rob needs some time, and I'm going to have to stop. We'll just do. We'll do it. Do you how much? Yeah, a couple more minutes. Right. So we'll just get to the end of. We'll just try and get to the end of these, and then. Bad design, lift buttons.
So it's kind of hard to see, but it's like the most stupid lift design I've ever seen. This was in a student building back in Wellington, and all the buttons are just glass panels. You can't actually see any numbers. So
You have to guess.
yeah, you have to look really closely, and there'll be like a slightly different shade of white and a number. And the first one there, you can see it has a little circle on it. It kind of indicates you have to press the circle, but you actually have to press above the circle.
Is it an office building or a hotel?
It's student accommodation, which also makes it really funny when people come back on like a Saturday night.
Why? What's different on a Saturday night?
Yeah. I know somebody who does user interface research for drunk people. Yeah. Great. I've got another good lift anecdote. Has anybody ever seen one of these lifts? So they have one in the Facebook building in London. They have a lift where you go up to a console and you press the floor you want, and then it tells you to lift to get in. And inside the lift there are no buttons. Right? So you get in the lift and it takes you to the floor that you said you wanted to go to and no other floor. So basically the operation is people get in the lift, it takes them to one floor and then comes back. So it's just doing this all the time. So I'd seen this before, but the first time I seen one was in a hotel in Glasgow with drunk people around, right? And they had to have a physical person there, asking them which floor they were going to and then telling them to not get into the first door that opens, because that's not going to the floor they're going to. So they had to physically stopping them getting into the lift because they went to wait for the next lift. There's lots of lifts, there are 4 lifts. And they had to, on a Saturday night, they had to have somebody, a bouncer, essentially stopping people getting in the lift because they'd go up to the floor, get out, and then be on the wrong floor, and then have to come back down again. So those are getting more common. They are actually more efficient. So from a building owner point of view, you want one of those lifts. It's just much more efficient for an office building, but obviously you need to retrain everybody who's ever been in a lift because that's quite a lot of people. And then the right one, product designer got it wrong.
It just sits like centered, and you have to use trial and error to figure out which way to flick it.
Yeah, so there's a button on the inside of the handle. Presumably you can do it accidentally when you pick it up as well, yeah. And then wonder why your kettle's boiling when you put it down. So there's lots of ways that can go wrong, yeah. That's okay, so great. And then just one more, and then I think there's only one more. Eduardo, is that? Oh, sorry. Is that yours? Yeah. Oh no, you can't see anything. I can see it. Paper clips.
I was thinking about simple designs, and then in front of my desk there was just a paper clip, and I thought, oh, that's a way to do design. It must be because they are simple, there's flyweight there. You can travel with it and use it anywhere.
And you can unfold it and get your SIM card out.
Yeah, well, so, I don't know who was the designer of paper clips, but
They're actually patented. I read a book on early patents, and paper clips are patented, and before that design there were other designs of paper clips, yeah, which weren't as efficient. Yeah. Yeah. It's great. Yep. Magnetic whiteboard erasers.
just behind, yes, basically, it's just
They-
an update.
This is such an improvement,
Yeah,
right?
it's an improvement, but I think that is quite,
Yeah.
it's quite good.
And it took, the key thing is we look at this now and go, somebody had to think of that.
Because in my case, it was getting lost, so basically
Yeah.
now it's just, you can just save it on the,
And Google Cardboard. Do you mind if we park that one for a later time? Google Cardboard. I mean, it's a great idea. It's dead cheap.
Yes. So it's not just the Google Cardboard or any other cardboard design for using the cell phone. It's also the interface. I think that's quite simple to use.
Yeah.
It doesn't require so much instruction, and basically it doesn't have so many buttons, so it makes everything
Yeah.
easy to use.
You can come back and talk to me and Rob in a few weeks about what were the problems we have with it. But yeah.
So,
Okay,
well,
bad.
Yes, I probably should come up with a picture there, but we have the microwave button. So basically, there are too many buttons on the microwave. Sometimes I just want to keep my lunch, and there are so many functions. I really don't know what are all the icons and descriptions. So basically,
Yeah.
it looks like making things a little bit tricky than making things simpler.
Yeah, it's a case we'll get into that the microwave only does two things. It has a different power and it has a different length of time. So my microwave has two buttons. One is the power and one is the time. And that, because that is actually what is going on inside the microwave. It doesn't do anything else, right?
Oh, there's the popcorn sensor, man. It's stopping the popcorn stuff. There's magic going on.
Magic.
No, really, it will be quite impossible to learn about all the buttons. I mean, like.
Yeah.
all
And then the final one, the sinks. Is that-
So basically, about my one thing,
Yeah.
is just the taps are too close from the edges. So from the edge, so actually I have to reach really close from the edge to get some water, and I just spread everything around. And
Yeah.
the other thing is, it's the cold water tap and the hot water tap. And now there's this new design, which is just one tap where you can just swim it. You can get hot and cold water and even warm water. So I think that's a pretty
Yeah.
much good design.
The bathroom, the kitchen here has 4. I mean, it has hot, cold, really, really, really hot, and somewhat cold. They're in 2 different sinks. And in the UK, if you get one of these things, one of these hot, well, they're called zip, we call them zip taps. I don't know what they call them over here. The ones that just give out water that's just close to boiling, but not sufficient for a cup of tea, so it's not that hot. It has a sign on it saying this water is hot. I think it's great. I tried to get a photograph of one, but everyone I've seen around here, they just let people burn themselves, so, scald themselves rather. In the UK, there's always signs. Yeah, great. So good example. I mean, this is why you can buy magazines on design, right? It's a problem. So the 2 taps thing is a hangover from the English, because the main complaint we get in England about from tourists is we don't have mixer taps. And the reason for that is that water systems in houses in the UK are different than American ones. They're literally set up in a different way. So you can't, it's illegal in the UK to have a mixer tap, technically, because of the way the water works. Now, of course, there are, but they do have things that look like mixer taps, but they don't. They actually only mix on the outflow of the tap, whereas in American ones, they mix in there. So, okay. So the reason for pointing that out is there are other design constraints at the back end. There are systems back there which you need to know about. So in the UK, you literally can't buy the same bath taps as you can in Italy, for example, or America. And something here. Right, okay, that was fun, I hope. Going through those, we'll do a little bit more structure over it, but I think Rob wants to give a bit of an overview of what the case example is of the for the coursework. So I will carry on with this next week. I've got more